50 parts per million. That is all a number that you should know, as well as you know what the Dow Jones is. Another way to look at this is to look back in time. I'm an ice core paleoclimatologist. I got to show you one piece of ice core data. This is it. This is a record going back 420,000 years. And that's a long time, right? 500,000 years. So this is from ice that's been drilled in Antarctica at a place called Vostok. And what you see on the bottom is how carbon dioxide has changed in the atmosphere over that last 420,000 years. And you can see the variability in it, and there's actually been 4 ice ages, which are well represented here. But you'll notice that the greenhouse gas content has never been above 300 parts per million by volume, carbon dioxide in the atmosphere. If we add to this the curve I already showed you from Mauna Loa, we're now up at about 385 parts per million by volume. We've already changed the carbon dioxide content of the atmosphere by an amount that's equivalent to a shift that we see between a glacial and interglacial age. We've already dramatically changed the climate system. Why do we care about carbon dioxide? It's a key greenhouse gas. I won't bore you with the physics. What I'll tell you is greenhouse gases are just like blankets you put on your bed on a cold New Hampshire night. That blanket serves to trap your heat and keep you warmer. Greenhouse gases in the atmosphere serve to trap the long-wave radiation coming from the Earth and increase the temperature of the planet. More greenhouse gas, the temperature goes up more. If we're not careful, we're actually going to end up where we're going. That's going to mean if we continue to rely upon fossil fuel as our main source of energy, by the end of this century, we're going to end up with carbon dioxide content in the atmosphere at about 970 parts per million by volume, which will result in catastrophic climate change. That's where we don't want to go, but that's where we're going if we don't change the pathway that we're on right now. Conversely, if we invest in clean energy and energy efficiency, we might be able to level off our greenhouse gas content at about, I would argue, 450 parts per million in the atmosphere. James Hansen has argued that we actually need to stabilize and reduce our concentrations to 350 parts per million if we are to avoid catastrophic change. So that's where we're going, and that's our goal. And that's really a reason that we need to be talking about climate change, is because we are completely on the wrong path. One of the reasons I think the candidates aren't talking about it, it was alluded to earlier, is it's not in our face right now. Today, it's not a problem. And so we have the unenviable task of convincing politicians to do what's right today so that we can make a better life for our children and grandchildren. And while we talk about that a lot, we don't act on that a lot. All right. Here is probably, if you don't believe that our climate is changing, this is the graph that I hope changes your mind. Because this data is really shocking to the scientific community. Here we're looking at Arctic sea ice extent. June, July, and August, Arctic sea ice extent, as measured by satellites. We're going back over about 100 years. The satellite record boat begins in about 1980. Before that, it was just monitored by ships. But we just look at the record since 1980. You can see this slow, steady decline in the amount of Arctic sea ice down to 2006. And then last summer, we lost that much sea ice. We lost an additional 25% of the sea ice in the Arctic. And in 2008, it's about at the same level we've seen in 2007. There was no scientist 5 years ago who predicted that there would be a catastrophic loss of sea ice to this extent. We are now seeing the Earth system change much more rapidly than scientists predicted 5 years ago. In some ways, we blew it. And now there's talk of the Arctic sea ice disappearing during the summer altogether within the next 5 years. Why do you care about Arctic sea ice? Because it's the air conditioner of the Northern Hemisphere. It serves to reflect incoming shortwave radiation because it's white, serves to cool the planet. When you get rid of that sea ice, the Arctic Ocean is going to start absorbing that water, the Arctic Ocean is going to heat up, and it's going to be really hard to ever build that sea ice back up again in a significant way. This is a global environmental change record that I would argue is far more important than the Dow Jones.
Looks like a Dow Jones.
It's not nearly as variable. The down just keeps going. All right, I wanted to share a little bit of information or data on how our climate's changing across the Northeast. This is data from a graduate student of mine, Liz Burakowski, who's just finished up her master's degree. And she's been looking at changes in temperature in red and changes in snow cover in white across the northeast US. And what we have plotted here are the monthly changes in temperature in degrees Fahrenheit per decade. So it's really the heart of our winter, January and February, where we've seen on the order of 1 to 1.2 degrees Fahrenheit per decade temperature increase in our winter across the entire Northeast. So we're looking at 3.5 to 4 degrees Fahrenheit increase in the heart of our winter. And that's a significant change, much more rapidly than the global average is increasing. When we also look at snow-covered days on the right-hand side, you see January, we've lost about 5 days per decade. That's 15 days over a 30-year period. And then in February, we've lost on the order of 2.5 days per decade. So we're looking in January, we've lost half of our snow-covered days in January over the course of the last 3 decades. The two are intimately linked. Just like Arctic sea ice keeps it cool, there's a fundamental link between snow cover and temperature in the Northeast. So we're seeing warmer winter temperatures, which are reducing our snow cover. As we reduce our snow cover, our temperatures are getting warmer because the ground is darker and it's absorbing shortwave radiation. All right, so that's sort of in the past. What might happen in the future? These are just a few results from the Northeast Climate Impact Assessment. If you're interested, there's a wealth of information on this webpage called climatechoices.org, a whole series of reports, state-based information. I just want to share a couple of potential impacts of climate change on the region. Perhaps one of the most important is what's going to happen with sea level rise. And what we decided to do was look at what would the area that commonly floods under the 100-year flood, how would that area change? And we've used a relatively moderate estimate for sea level rise of 16 inches, which occurs under a high emissions scenario, but also one that just relates to increasing sea level because the temperature of the surface ocean increases. Warmer temperatures, less density. It doesn't include the melting of Greenland or Antarctica, or parts of those. And so the 100-year flood is very important for planning purposes. FEMA puts out a whole series of 100-year flood maps. It's difficult to see, but if you look over here, you can see this cross-hatching area, right? So we're looking at downtown Boston. Here's the aquarium, here's Faneuil Hall, here's the Boston Garden. So under this scenario, this area here in crosshatches represents the area that on average is the 100-year flood zone. So there's a 1% chance in any year that that area is going to flood because of the storm surge. That area, under 16 inches of sea level rise, would become the 2-year flood zone. So there'd be a 50% chance any year that that would flood. And this whole area in blue becomes the new 100-year flood zone, under 16 inches of sea level rise. One flood of this magnitude would cost the city of Boston something on the order of $70 to $90 billion. And it would be really hard to drive through the Big Dig if this happened. The flood would also top the Charles River Dam and get into Back Bay. So you can see here Commonwealth Avenue and A here, all of Back Bay floods as well. So this is under a moderate estimate of sea level rise. A recent paper just came out in Science magazine that had good news and bad news. The good news is it's unlikely that sea level is going to go up by more than 7 feet because of melting of the Greenland ice sheet and warmer sea surface temperatures. The bad news is that sea level might go up by 7 feet. If sea level went up by 7 feet, what you're looking at here is high tide in Boston. And that's just not going to happen in Boston. That's going to happen in every major city around the globe, resulting in literally hundreds of millions of environmental refugees. All right, that's the depressing part. Now here's the good part. Why should we be talking about climate change? I think probably the most important answer, and it's even more important today than it was 2 months ago, is that figuring out how we reduce our greenhouse gas emissions is linked fundamentally to renewable energy and energy efficiency. And if we invest in that, we close that energy loop, dollar, so that dollar gets spent in our economy, it's good for our economic development. Reducing greenhouse gas emissions is in fact an economic development plan that we need to invest in now. So just let me finish up with this slide. This is a result that has come out of the New Hampshire Climate Change Policy Task Force. Governor appointed, lots of businessmen on it, heads of all the major agencies, and one academic.